here. Thank you, everyone, for joining us for today's Genesis webinar. It's hosted by Nucleate Arizona and BioLaunch at Arizona State University. And we are so excited to have Dr. David Giltner here today. Before we start, I would like to introduce Nucleate and share a bit about what we do. Just a small screen sharing. Okay. So, so for those who may be new to Nucleate, we are a global nonprofit community that empowers the next generation of biotech leaders by educating today's academic students and trainees. We connect people from different universities and industry to share knowledge, collaborate, and then finally turn their new ideas to real world impact. So, our goal is to make biotech education free and open and accessible for everyone. And in here in Arizona chapter, we continue this mission through events like this webinar and other hands-on opportunities like our upcoming Bio Challenge, which is happening on October 25th. So I would like to say a few words about Bio Challenge. It's a full day innovation competition where students can form teams. They can choose from several ASU patents and transform it into a startup concept that address real world biomedical or environmental problems. So teams will pitch their ideas to a panel of expert industry judges, and they have a chance to win $5,000 in team-based cash prizes. That's huge. It's a fun and inspiring event, and that lets you learn the fundamentals of startup creation, connect you with other innovators, and see how technology commercialization can actually turn your research into real impact. If it sounds exciting, please visit our Nucleate Arizona LinkedIn page to learn more about it and sign up. And if you would like to are interested in getting more involved and join our team, we are always looking for students to join our team to help plan our events and contribute to our growing biotech community. And you can always reach out to our co-managing directors, Josh, Aiden, or Patrick, who are also here, or message to our Arizona LinkedIn page. And that's it now. I'm really excited to introduce our guest today, Dr. David Giltner. He's the founder and CEO of TurningScience. I've had a chance to get to know him a bit, so I hope it's okay to call him Dave during our chat today. So,
Definitely.
Dave has more than 25 years of experience helping scientists and engineers bridging the gap between academia and industry. Through Turning Science, he had trained several researchers at more than 60 universities around the world, teaching them how to communicate their research in business terms and succeed in industry careers. So he is also the author of several books, which has helped many scientists make this transition successfully. And so we are so glad to have him with us today to share his insights and advice. So, with that, let's get started. Dave, once again, thank you so much for joining us. So, I just gave a brief introduction or just a small intro about yourself. Before we start, do you like to add anything more or share something with the audience first?
Well, that was a great introduction. Thank you so much. And absolutely, you can call me Dave. Thanks for bringing that up. That's what I go by. So, yeah, it's I don't know if there's a need to say anything else. I'm happy to answer questions about, my company and how I got here. It's been an exciting journey. I started my career in industry and I've spent most of it there, but the last few years, I guess it was in 2017 is when I started Turning Science. So I've been doing that since then. And it's been a very exciting and rewarding journey. It's very fun to build something that's your own idea. It's hard to describe just how cool that can be. It, of course, comes with its own challenges and uncertainties and many things, but it's been really rewarding. And the biggest part of it is being able to help people who are following the journey that I have followed and have enjoyed so much. And more than that, to help all of you go off and do amazing things to make the world a better place. It's exciting and rewarding. So,
Thank you. That's a great introduction, and I think that sets the stage for today's topic. Like, you founded Turning Science to help scientists bridge this gap between academia and industry. So, what, it's obvious, but still, what inspired you to start in, and why do you think that mission is more relevant today? Like, as we move on, how is it more relevant today?
yeah, so there, I hear two questions in there, so I will take them one at a time. First of all, what inspired me to do it? You know, my journey that ends up starting Turning Science started when I was a graduate student. Like so many of us, I like science. We follow that traditional path to become a scientist, right? You enjoy it in high school or whatever your path is. I declared physics as a major. I liked all kinds of science, but I found that you don't have to memorize as much in physics as in biology or chemistry. And so my physics, I remember the day my physics instructor, physics professor said, we will talk about a lot of equations in this course, but you really only have to remember one, and that's F equals ma, and we can derive everything else from that one equation. And I thought, I am in the right place because I had already taken a chemistry class and saw how much you have to memorize. So anyway, and then that if you want to be a scientist, you figure I need a PhD. And all along thinking, I guess I will be a professor because that's where scientists work. That was my idea anyway. The traditional view, you work in a university lab. But about the last year of my PhD, after watching my advisor and the other professors for about 5 years, I thought, that's actually not the career that I want after all. It's fine for them, but I wanted something different than what I saw. My lab partner, his name was Roger, he had come in planning to work in industry and talked about how cool it was. He had done an internship, and I just thought, okay, I will try that. But I had no idea how to go get a job in industry. So I just started talking to all the companies I could. I remember even talking to Hewlett Packard, and they made printers that had nothing to do with my background. But I thought, I have no idea what I could do in industry. I have no idea what they need from me. And eventually I figured out how to find companies that needed what I brought, how to talk to people in industry, because that's very different than the way you talk to somebody at an academic conference, and how to get a job. Once I got the job, just learning how to be successful was a bit of a challenge. Of course, I needed my technical skills. Those were valuable. I was working at a laser company, and my grad school background was in laser spectroscopy, so there was a connection. But it's just the thinking and working habits are different that are required. And so I had to learn all of that, and that was an experience. Move up to about 2009, I enjoyed my career, did a lot of different things, but in 2009, there was a period I would say I was between jobs, which is usually a euphemism for I lost my job. And I had been working for a small company that had been acquired by a larger one, and they shut us down after a while. And I didn't want to move to California. So I was out of work for a little while, and I had an opportunity to write a book where you interview people. I met a guy who was helping, he had a little company helping you do interview books. You interview a bunch of people around some topic you're interested in, and he would help you put it in a book. And I thought, hey, when you have a book, people ask you to come speak, and that would be fun to have a speaking gig, right? And since I was looking for a job at the time, I was once again reminded of that challenge that some of us as a PhD scientist have trying to convince somebody in the very practical world of industry that I can be a good fit. And I was a lot better at it by that point, but it reminded me of that. And I thought, I know, I will interview scientists who work in industry because that would make a great reference manual. It would make the book that I wish I had had when I was graduating, right? And so I did that. I got a job and I started speaking on the side. I'd take a few vacation days and travel to a university and give a talk. And that's where I realized, boy, yeah, it was not just me. Many PhD scientists out there in many disciplines. I didn't just talk to physicists, struggle with this, both finding a job, understanding it's a different game, and then doing well in that job. I heard from a lot of industry managers who, struggled with their scientists, their PhDs, who continued to behave with an academic research mindset. And so by 2017, I had thought a lot about this and thought, boy, there's really a problem out there, and I actually think I can help solve that problem. And I'd had a lot of ideas about different workshop modules I could give, and how could I go beyond the 1 hour talk I've been giving ever since I wrote my book. And that's what led me to leave my job, start Turning Science, and start building what I'm doing now. In the last few years, I've written two more books on the topic, and now, kind of following that path. I had no idea where it might lead at any point. When I wrote that first book, I knew I wanted to start the speaking gig, but I had no idea I would end up starting a business and doing this full time.
That's inspiring, really inspiring. So, yeah, a lot of things that you have told, the culture difference, translation of our skills, how do we speak the industry language, which I still don't know. So that's something like many of our graduate students and postdocs still struggle to see that we do have a lot of research experience and we know we have a lot of knowledge, but how do we translate that into industry value? So, what are some of the cultural differences or mindset that we need to make a difference when we transition from academia to industry? And so, how do we reframe our experience or research skills to better fit the industry role we are seeking?
So it's a really important question. I'm sure everyone on this call is thinking about that. And this is what my second book, the blue one over here. The title of it is kind of the first answer to your question. So the title is "It's a Game, Not a Formula," and that describes in one phrase. It's a reminder I still use myself. That describes the difference between the mindset that I used in academic research that I feel we kind of come up with, even grow up with, and I'll explain that in a minute, versus the mindset in business. The formula thinking is kind of what we do in research. It's about finding the right answer. And certainty is a big part of that, right? You do research, you analyze the data, and before you publish it, you make sure that you can stand behind it, right? I really believe this to be right. Your team has reviewed it. You're very certain. And you'll take as long as you need. But industry moves fast. If your company's making anything worthwhile, you will have competition. And I say you'll have customers who need it yesterday, whatever the product is, need it yesterday. So you have to move really fast. That doesn't mean you don't have to be certain about some things. You don't want to ship anything, of course, that doesn't work or, that injures someone if it's the medical industry. But many decisions have to be made along the way before you know. It's much more like a game where it moves quickly. You have to take risks, So soccer or football, as it's called in most of the world, is a kind of a game most people know. I say, so formula thinking, every physicist would love to calculate a formula for how to reliably kick a soccer goal every time, right? And in principle, that can probably be done, but that's not how you play the game. You play the game by getting out there, it moves fast, you see an opportunity, and you have to just take a shot, and you might miss. So that is more game thinking. You have to be able to deal with uncertainty. You have to make decisions when you don't really know what the answer is. It's also much more of a team kind of effort than in graduate school. Some people say, well, we work with other people. Yes, but your PhD project is typically your own, and you're responsible for all of it. You have to stand up and know all the answers and defend it. And that's just not the case in industry. In fact, we have to shift from thinking, I have to know all the answers like we do for a PhD, to saying, I have my expertise and absolutely I contribute to the team, but I have to respect other people's intelligence, what they know, their ideas. They may have good suggestions. And if I don't know something, it's often quicker to ask for help. That's not really something we usually learn to do, right? In graduate school, usually we have to figure it out ourselves. So there's a number of ways that you have to shift from that, certainty takes the time it takes to fast moving decisions, focus on results rather than creating new knowledge like you do in academia.
Right. Yeah, so it's kind of we make use of a knowledge at the same time make use of the team's knowledge, not just driving it as a single person team.
Yeah,
Right?
yeah,
So yeah, I've come across places where we have this project to complete, but in academia we take 1, 2 years to complete that.
right.
But how do you explain that how these many years you took to complete one research project to an industry person who's interviewing you? I mean, what
Yep.
are the specific things you can highlight from that project? For example, I work on bioinformatics, so
Mhm.
I've learned that I should highlight certain things like big data. Like I've been analyzing like 1 million data sets. That's something I can make impressive about my project rather than saying what exactly the results were. So
Mhm.
those were the things that an industry person might be looking like how big the amount of data I've been analyzing. So that's pertaining to my field. Like, what is your suggestion that you would say that we should focus on when we are going for an interview, or what are the things that we think like we must be dealing a lot of things, but we might be ignoring such details. Like I analyze this big data, but I
Mhm.
just ignore that. I just move, focus on the results. This is what I found out, but that's not what they are interested in. So, what
Right.
are the things you think like a researcher, like academic researcher, should focus on right from the beginning? So when they work on this research, they know, okay, these are the things I should highlight when I'm trying to project or advertise myself in front of an interviewer.
Yeah, so results is a good one. I mean, that's one thing you pointed out, right? Why does your work matter? Being able to understand why it matters it's a big difference. Being able to describe projects you work on, something that you planned, you led, you executed, especially if there was a schedule. I know I didn't have a schedule as a graduate student. Now I suggest in the time you have left, if you don't have a schedule and deadlines and milestones, I suggest you draft a schedule and try and stick to it. So at least you can describe to somebody in the industry, hey, I know that where I'm headed, they manage programs and I better practice doing that, practice estimating how long it takes. So talking about the project, talking about your results and why it matters, why people might care, that is really useful. But a really important part of this, if you want to be able to describe what they want, it depends a lot on what they are doing. So, one of the really important steps that I describe, that I recommend, is to have a target. And what I mean by that, many job seekers, when I say, well, what kind of job are you looking for? They often say something like, I'm really open to a lot of things. And I always think, ooh, I understand that the temptation to be open to everything because there's so many companies out there, and maybe any one of them would give me a job. But when you do that, it's really hard to know what aspects of your experience to highlight. Whereas if you target, then you can describe something much more useful. So I'll give you some examples from my own background. You said something about yours, I'll describe mine. So I'm a physicist by training, and I know that's different than your probably most of the background here, but I worked in laser spectroscopy. We used lasers for tools, but the kinds of research that I did, first of all, we did a high precision test of special relativity, Einstein's theory that says clocks that go faster when they're moving fast slow down. And then I built an atom interferometer, which demonstrated the wave nature of matter. Well, the tools that I worked with were high performance, these sophisticated lasers that, provide a very precise wavelength and it's very controllable. I worked with vacuum chambers. I had to build a lot of hardware inside a vacuum chamber to hold mirrors and other mounts and stabilization systems and diffusion pumps and all kinds of different things. So I was faced with this question too. Well, what would a company care about? When I have a target and I narrow it down to one or two technologies or areas or market areas, I can start to understand what might they need. The target that I chose, I decided I would pursue companies that made lasers for scientific instrumentation. That was something that I had worked with as a grad student. It was only part of what I worked with, but it was an important part. And it turns out many of those companies were geographically concentrated in the San Francisco Bay Area. So I thought that would be great if I get a job at one, maybe I could build a whole career there, right? I wouldn't have to move if I changed jobs. So that was my target. That allowed me to start to think about what aspects of my work would matter. So instead of saying, I excited a two photon transition in a metastable neon beam as a test of special relativity, because that wouldn't mean anything to them, I could say I'm an expert with tunable laser systems like the ones that you guys are building. If you're developing the next generation, I understand what the current version does really well. I understand what it doesn't do very well, and I would love to help you fix because I've been struggling with them for the last 5 years. I understand the kinds of experiments your customers use these for because I've been your customer for the last 5 years. So these are examples of the kinds of things I might talk about. And interestingly, what I'm talking about aren't technical skills per se, but they're absolutely things that would be relevant to my target companies. I can only do that if I know who I'm targeting. If I stay open to everything, then I'm stuck saying, well, I did a test of special relativity and I built an atom interferometer, and the companies are going, whoa, we don't do either of those things. And
Yeah.
of course, then I can start to get into more detail about things that matter. What results? Well, have you led a project? Did you solve some problem? I'm big on telling stories, not just I'm telling stories now about my background, but in, say, an interview situation or things like that, where I describe something that I did that sounds relevant to them, problem I solved, and that something that would make an interviewer think, oh, that is the kind of thing we do. Yeah. There's a stereotype of a PhD scientist that you just want to study a problem for 5 years and write papers. And what you want to do is break that stereotype and help them see what you want to do is tell stories about things you've done that make them go, oh, well, that is a lot like things that we do here. But of course, you can only do that if you've got a target and start to research what does this company even do?
Okay. Yeah. Interesting. Yeah, that makes me think differently because we have covered a lot of things during our graduate years. So we are thinking like, yeah, I'm open to all those positions. I've done this, I've done that. Maybe I can apply to all those positions, but no, there might be some gap in the industry as well where I can target, where I have specifically found some gap while I was doing the research kind of thing. Yeah.
It is tempting to say, well, there's all those companies, right? And because of the large number, it feels like if you could apply to a large number of companies, your probability is higher. But the problem is the probability of securing any one of those jobs is low. And so you add a bunch of small numbers together and the number is still small. If you reduce the number of companies, but then you're able to greatly increase the chances that they see you as a good person for the team, that actually is more effective.
Right. Yeah.
So that's what
Thank
that's all
you.
about. It's kind of like
That's
going
a big
hunting.
eye opener for me.
It's like
Yeah.
going hunting instead of fishing, right?
Yeah. Yeah.
If you're going to address all these companies, what do you do?
Hmm.
What a build your LinkedIn profile, apply, send your resume out. I mean, you're not really actively doing much, right? You're just putting it out there and hoping the right thing comes along, like fishing, as opposed to get
Yeah.
out and pursue them. And when I say pursue, I mean more than apply online. I know that's kind of the standard way, but that's you're probably aware that's you don't have a lot of control. You can try and put the right keywords in it. What I suggest is meet people who are working in that industry or at those companies and talk to them because that's how you really start to learn what they need and make connections.
Yeah, yeah, that was one of my questions. So, for us, networking, I mean, we are just used to communicating or presenting our research. So, we are not used to communicating with any of those managers or business people. So, we
Yeah.
are used to the technical terms that we don't know how to communicate with. So, how do you think, like, how important or how do you think can we start networking and learning to communicate effectively with those so-called non-scientist managers or business people?
Yeah. So that is an important thing to do. And as early as you can, conferences are a great way to meet people. And one caveat that I was not aware of when I was looking for a job is I just started going to the trade shows at the conferences that I already attended. But what I didn't appreciate is those really were very heavily science focused conferences. And while there was a trade show and companies would come to the trade show at the conference, they were only the companies that were trying to sell instruments to the scientists. There are industry focused trade shows that often are far bigger. And so my industry, the laser industry, the industry one, so the science one is called CLEO. It stands for Conference in Lasers and Electro Optics, right? And that's where we used to publish our research. Trade show was small, but I didn't appreciate this. I learned that there is this conference called Photonics West, and that is industry focused. Many of the talks are applied. The trade show is 10 times bigger, maybe more, because every optics company around goes to that one. Had I known this at the time, I would have focused that one on that one. That's a great place to
Okay.
meet people, and that's a good start. Now, LinkedIn is another great resource. And again, when you have a target, it changes how you might use it. A lot of people imagine you build a profile in LinkedIn, and if you have the right keywords, then maybe recruiters from all these companies will come find you. I don't know how effective that really is. What is really effective about LinkedIn is the search function. When you have a target, so in my case, companies that make laser instrumentation, for example, I can start to search on keywords related to that, and I can find people, I can find companies, I might find groups related to that. I can follow the people in the companies. I can find out where the companies, what conferences they're going to, or if they're doing a webinar on something. I can see what people are posting because people will post about their work area. Some people like to do that, right? And you can learn an awful lot about your target area. And a lot of times you can find people you can learn from. Let's suppose you see a few people who post pretty regularly about their technology area. You can comment. Maybe you have a good question to ask to engage them. And if they answer you, if this happens, right? You can get in a conversation with somebody. That might be a great person to do an informational interview with. Reach out to them and say, you seem to be established in this field. I'm really trying to get into this market, this segment, this whatever your target is. Could I spend 20 minutes with you on a Zoom call and just kind of ask you about your career and your job and how you got to where you are? It's kind of like asking directions, right? Not asking for a job. That's always too forward. But just learn from them. You never know what you're going to learn about, find out about. That's a great way to get started.
Yeah.
Both of those. So that you got two there, right?
Mhm. Yeah, yeah. That's I mean, strategic way to do the search rather than filling your resume. Yeah,
Yep.
understand. So yeah, another important question I framed was about the way we perceive a failure.
Hmm.
Because in academic, failure is always personal. We
Yeah.
failed. We feel it as personal. But when it comes to industry, how can we early career scientists reframe such failure or setbacks as a valuable learning experience or convert them as a precious experience when we talk to the hiring people?
Yeah. So, the funny thing is in industry, people see setbacks, failures, things not going the way you expected as just part of the game. And this is part of why I say it's a game, not a formula. Think of a sport. Let's go back to soccer, football. Good players never make every shot that they take, right? That failure, missing a goal is just part of the game. And especially if you're just getting into the game and you're not a pro yet, you have to take chances. This is part of the risk that is the game. You have to be used to trying things and knowing that it won't work. In industry, people realize that's the way we learn. We try things. Your manager wants you to be willing to try something that might not work. And we're not talking about shipping something to a customer or doing something that's damaging, right? We're just talking about trying something here. But that you described, that sense of failure is really strong in us from kind of the academic upbringing that we have to be right, we have to know the answers. I didn't really go into this, but this is the formula thinking that frankly we grow up with. I mean, we go off to school when we're young, and what do we learn? They give us a test, and we learn that if I get all the answers right, my teacher's happy and my parents are happy, and I get an A or whatever the grade is. And you learn that that's the game all the way through school is to be right, to have the right answers. You want to get the A plus, you want to get the gold star, right? And those of us that are going on to PhDs, we were probably that more responsible, wanted to get things right. It is hard to shift our mindset from I need to do things right to I need to try things and it might not work and that's actually okay. so so when it comes to, I like to say I talk about telling stories, but some of the things I suggest you tell stories about are when you had a problem in your research, especially if you fixed it. We can tend to shy away from that because we think like if there was a problem, maybe they'll think I didn't plan it well. But problems happen all the time in industry, right? I say everything is a project. We say, okay, over the next 9 months, we plan to get from here to here. This is what we're going to deliver. These are the milestones along the way. That doesn't mean that we think that's the way it's going to go. Problems happen because we're doing it for the first time. You want to try and get back on track. But what industry needs are smart scientists who can solve problems. So it's really kind of to get back to your question, how do you deal with failures and problems? I would say own them and realize that that is part of the game. If you can show them that you had a problem and here's how you fixed it, or maybe even that you learned something from it. I like to say, tell stories about lessons, about things you learned. It's okay to say, I came into this project thinking this, and I realized that wasn't right at all. I learned this and I learned this and I went away a lot smarter. That's actually what your manager wants to see. You don't need to make them think you always had the right answers. It sounds counterintuitive coming out of an environment, the formula thinking where you always had to have the right answers. But that's what they want. They want somebody. We're doing things that nobody's done before. So we need people who can get in there and just try something, see if it works. Try, not be afraid to do something and go, oh boy, that didn't work. I was wrong with that. But now I know better, right? That is the attitude. So, you know, framing your academic research experience in this way can actually be really important. And, notice as I talk about this, I'm not even talking about technical skills. Of course, technical skills are important, but this is really key. Much of what they're looking for is not technical skills per se, or I should say, yes, you need to have technical skills, but there are many other things that you don't even think about much in research. How do you deal with a problem? How do you deal with a challenge? Are you willing to move quickly? Do you realize that results matter? These are important things hiring managers are looking for. And we don't even think of them as skills in a research lab most of the time, but they're really important to them.
Yeah.
When we talk about the stereotypes that exist of PhDs, it's usually that we don't do that. We work until we have the right answer and then we speak. We can't make a decision. We can't move quickly.
Yeah, yeah, true. So, yeah, so that comes to the next question about this transferable skills, which you mentioned about. So, like we deal with a lot of research. While dealing with research, we are communicating with a lot of people like students, mentors, collaborators, and things, and other scientists. And we also have experience with leadership, like mentoring other students, like undergrads or grads, and teamwork. So how do we utilize all these skills and pivot them or utilize them to different roles in the industry? Because all we know is doing research. How do we transfer all these different skills other than technical expertise into something achievable for different roles in the industry?
Yeah, so the more you can learn about some of these roles, the better that will help you tell stories about the skills and the thinking habits that might be useful there. You're absolutely right. There's a whole section that I have in my workshop where I talk about what are some jobs that scientists can do, because most of us just think of research scientist. And that is something you can do in industry. But there are so many other things related to product development. Some people go into technical writing, some people work for a patent office, so many different things. If you can find something you think you might be interested in, then you can do a few informational interviews with people doing that kind of a job, even if it's, 5 years, even 10 years down from like an entry role you might get into, and understand from them, talk to them about what do you do in a typical day, because that can really help you understand what is a day like and what are some of those non-technical skills that might be useful. We have a lot of different things. So another part of the workshop that I do is I'll walk people through, well, what are some of the strengths that scientists have, that any scientist has, not related to biology or chemistry or whatever. Well, we solve problems. That's something that we do that's very broad. We're very analytical. We make data-driven decisions. That can be valuable. We aren't afraid of the unknown. That's an interesting one that most people don't think of. Like, that's a strength. Yeah, that's a strength. But understanding, talking to people that are doing a job you're interested in is an awesome way to get more detail, much like telling the stories on your target. That allows you to think, okay, what have I done that applies to that? And it might be a research, it might be you have a hobby, or it might be you did some volunteer thing and there's some leadership skill or something you demonstrated there that could be useful, right? It helps you mine your experience for things that might actually be relevant to an industry manager.
Thank you. So yeah, so you talked about the specialization, like how focusing on one area could help us land us on a job quickly rather than fishing kind of thing.
Right, right.
Um, but many of us worry a lot about becoming too specialized in a specific topic, um, where we think building a cross-disciplinary or gaining expertise in different areas would help us find a job. So I coming back. This
Yeah.
makes me coming back to that topic again, because we try to focus on one thing, but we still see cross-disciplinary skill set is what helps us to land more jobs. So, how do we find that balance? I mean, how do we decide whether we need to focus or when is the time to focus on multidisciplinary, given all this AI and everything is there now?
Yeah. So I'm glad you asked about that, because I should clarify when I say have a target, that doesn't need to be very specific technical niche that might not be cross-disciplinary. It could be wide. So let me give you some examples. It could be something sort of narrow. It could be, I'm excited about nanofabrication technology. And so that's what I want to do. That's fine if that's what you're really interested in. But another example might be I'm very interested in sustainable energy. And that can be broader. It may sound like it's chemistry or physics, but that could be very broad. Or maybe it could even be something in, say, medicine, a specific disease, and you'd like to help cure that. Well, there are many aspects. When you start looking, any angle like that is more than just, in that case, say, just biology or medicine, right? There are many aspects to solving that problem. It might involve all kinds of different things. I know physicists who have started companies even developing medical devices. They didn't know anything about the biology or about medicine, but they brought an optical technology that actually was able to provide a solution for something bigger. And they actually had to learn biology, and they had to learn something about medicine, and they had to learn something about how you get medical equipment qualified. So a breadth of experience is actually very relevant. I rarely tell people, no, 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 you need to narrow your technical discipline. It's more find a certain segment within the market where you understand the problems that are being solved. But the solutions to those problems might be very multidisciplinary, and that's great. That's awesome. So, yeah, I fully support a broad range of skills and understanding that. I think that's probably always good. I've led my whole career as I would say a generalist, still kind of within physics, but lots of different things, and I think that's great. It's really more a matter of narrowing to something you're interested in. And that thing you're interested in might be very multidisciplinary by nature. Companies aren't really discipline specific. I mean, of course, there are life sciences companies, which are primarily biology. There are chemical companies, but the approach in industry isn't, we don't go in through the discipline. A company says, here's a problem. How can we solve it? And they'll bring in whatever scientific or engineering or other discipline to solve that. And, they don't need to focus. They don't see a need to focus. So generalist or broad ranges of skills can be very applicable. Did that help
Yeah, yeah,
clarify?
definitely. Yeah, yeah. One last question before we open up to the audience. So,
Sure.
if you could give one piece of advice to your younger self, it's a cliche question. I know back when you were still in the training, what would you tell yourself when you're starting to prepare for a career in industry?
Yeah, think bigger than you are. That would be it. And I'll give you a little background. I know at the time, in fact, I talk about this in my workshops too. I show a photo. I got to be on the physics department catalog because, it was a laser lab. They wanted to take photos with all the cool colors, right? And I realized I had such a narrow idea of what a PhD scientist could do. I kind of like we were just talking about, I thought, okay, I can do research. I work in a lab. Where is that needed? Now I see there's such a huge spectrum of things that we could do. Some might not even be technical per se, where maybe not, I haven't worked in a lab for a long time, but the problem solving and the understanding of technical issues and the analytical thinking and comfortable with uncertainty in data, I mean, all those things still apply. So the message is look around and try things and look to see what are other scientists doing because there's actually a very wide range. Your PI, your PhD advisor may have a very narrow window as well because they've always been in academia. Nothing wrong with that, but they don't really see the world outside them. Now that I've been outside for more than 25 years, I'm just stunned at all the things I see PhD scientists doing. And I think, wow, okay, I would have encouraged myself to look more broadly early on.
Yeah, thank you. Thank you so much. That was so insightful. And I think all of our audience must have taken away some or a lot of things from your experience and examples. I would like to open up for questions from the audience.
Okay.
If anyone would like to ask, or feel free to unmute, or you can just put it in the chat.
I have a question. Can you hear me?
Yes.
Yeah.
Yes.
Cool. Thank you for the insightful discussion. I wanted to ask, because you were mentioning a bit about the importance of being a great fit to industry, especially when you're transitioning from academia to industry. However, sometimes I see that the problem is when we join a doctoral program, we need to first show that we are a great fit to the doctoral program. And
Yes.
frankly, the doctoral program doesn't operate the way that the industry likes. So, like, how do we push the universities or even our advisors, just our academic advisors, to have that mindset shift? Because they've been applying formulas their whole life. That's why they ended up in academia, and nothing is wrong with that. But how do we tell them that we want to play the game?
Yeah. A really good question. So, the first thing, of course, is if you're thinking about how can you persuade your your professor, your PI, your PhD advisor to adopt some industry mindset. It is absolutely possible. And if you're successful at that, that is an awesome story to tell. I have met many researchers who actually do embrace more of an industry mindset in certain aspects of their lab because while the formula thinking, we have to be right, we take as much time as it takes and don't publish until it's right, that is fundamental to research. But I've met many researchers who say, however, when we're building an experimental setup, for example, that's a lot closer to building a product. We don't often think of it that way, but they actually train their PhDs and postdocs to think more that way. When I was doing the interviews for my first book, and I repeated them in my last one, Shaping the World, because they were so good, I met a couple of researchers who were working in labs that ultimately got the Nobel Prize, which is the pinnacle of academic research, right? So clearly they understand how to do science research. And yet they had many of these, their advisor trained them in these industry kinds of move fast and get results kind of mindset. They learned to embrace both. And when it was about a deep understanding and a certainty, then they were using more the academic research mindset. And when it was about putting something together to get a solution, that's really more the industry mindset. And so if you can approach your PI and say, hey, look, most of us are going to end up out in industry. We'd like to talk about some ways to practice an industry mindset here in research. That can be a powerful persuasion and a great opportunity to, as a team, think about how can we practice this. And first you need to think a little more, learn a bit about, well, how do companies operate and where might we see opportunities to practice that? Scientists that understand both mindsets, I call it academic or research mindset, and the industry mindset I sometimes call development mindset. So it's like research mindset, development mindset that goes with the R&D that we talk about. Scientists that understand both and can decide when to use which one become very versatile and very influential in any sphere, including in industry. So I think that's a great challenge to take on, to approach your PI and say, hey, I'm looking at an industry career. I think a few of us might be. How can we practice that and go from there? I think that would be like I said, it'd be an awesome story to be able to tell in an interview that you actually persuaded your PI to adopt some industry mindset and help you guys practice in the time you had before you graduated.
Interesting point. Thank you.
You're welcome.
Any other questions?
I actually talk about this. If anyone's interested in my second book, is the one that's right here. It's a game, not a formula. There's an audiobook version and a Kindle version as well. But I talk about those mindsets and how that is something that you can bring into academic research if you want.
Cool.
I do
Can I
have
ask,
oh, so sorry. Go ahead.
can I ask a little bit about your like narrowing in on a target approach?
Yeah,
So
sure.
I'm early career, looking to hopefully pivot, but I don't really know. Like I know the strengths I have and the types of things I enjoy, but I don't
Yep.
necessarily have like this is the one role, this is the one area I want to target. How do
hmm
you sort of navigate narrowing that down and then especially when it is a pivot, emphasizing what you do have to show that you can like grow and achieve that pivot, if that makes sense.
Yeah. So I always suggest a great question. How do you build a target? How do you come up with a target? I suggest start with something that you're interested in, that you're excited in. Start looking around in industry. I mean, and it could be anything from, well, okay, AI is really big, but I mean, some people are just like, oh, I want to get in this. Okay, fine. That is, that's its own race to the top. But other people, there's a disease that they want to cure, or there's just something that excites them and they're not really sure why. That can be a great place to start because if it's something that really grabs your interest, you'll do better researching it. You'll do better explaining to people why you're good for it, to be on the team. You'll do better in the job. And as you start learning about it, that can help you better understand, well, is this what I want? Do I change my mind? And understand a target does not commit you for your career, right? We are well past the days where you get a job and you keep it for your career. I think everybody knows that. But just to be clear, a target, you can always change your target. You can start researching it, and a year from now think, oh, maybe that's not really what I want to do. Geographic considerations are also there, though. Once you think, you say, I think I'd like to work here, then look at, well, what are some of the companies? It's easy to research what are the companies that are in your target area. Are there a lot of them? Are they where you are now? Are they somewhere you'd like to live? Might there be an opportunity to go abroad? Some people say, hey, I'd love to move to another country and pursue this. That can help you understand too. And then the informational interviews, reaching out and finding people doing it, that can really help you decide, is this something that you want to do or not? And again, it's not like it has to be really, really narrow. It's just you want to have something to aim at where you can research them. You can't research every company in the world. So narrow it enough that you can research them. You can understand the problems they're solving, decide if you'd be excited to work at that, decide if you have a background that might fit that or not.
Thank you so much. Appreciate it.
You're welcome.
And then I do have a quick question. So a lot of
Yeah.
the talk we've done today has been about like PhD or postdoc level
Mhm.
students. For undergraduates who love lab work or have had like previous research experience, what are some of the best entry level roles or training paths that can open like that door to industry careers? Also, does like any of this advice change in those like an undergraduate or master's levels interview, or would you say a lot of the advice you've given previously is pretty applicable?
Well, certainly the, strengths that you might have can be applicable, right? I mean, obviously, someone who's done a PhD has a lot more training and probably has developed a lot more skills. The one thing that sets undergrads apart usually is they haven't spent a lot of time in the lab, and they usually haven't developed those academic research mindset, those thinking habits that can frankly be a challenge moving into, in some ways, PhDs have extra challenges because we're trained to be academic researchers, and then we have to modify those thinking habits to do well. And that's why I have talked to managers who complain about their PhDs and say, we actually have more luck with our bachelor's and master's students. Why? Well, it's because of those habits. I mean, it sounds terrible, like more training and they function worse. It's only because of the mindset. Once they get the mindset, they're good. But somebody that comes out with a bachelor's usually just been trained in knowledge, but not how to work generally. I mean, I know some get some research experience and that's great, but it's not like 7 years lab work or something like in a PhD. So the general guidelines, the things you want to talk about are all still the same. It's usually they just have a different set of experience they're working with and don't have to modify, don't have to worry about bringing the deep research habits in. So,
That helps a lot. Thank you.
okay, sure.
Yeah, maybe we have one more. We have time for maybe one more question.
It's
If,
real quick if no one else has stuff.
yeah, sure.
How do you sort of navigate the gaps on like desired qualifications? Like at what point can you sort of say, okay, I have enough, I think I could do this, I have the potential to learn to fit these qualifications, or is it just I don't meet that, don't try?
No, you know, I always suggest you don't need to have every qualification. And there's a variety of reasons, actually. One is that a hiring manager rarely finds a perfect fit. There's things that they would like to have. Job description is usually, it's a wish list, not a checklist. And sometimes, especially if you're talking about somebody who's hiring at a PhD level, there's not, as often not a really clear cut set of requirements. I like to contrast this. If I'm looking for a technician to solder circuit boards, that's a very clear skills and knowledge kind of job. I just need them to sit down and solder circuit boards. And so it's very clear what I need them to be able to do. But that's, very far from if I'm hiring a PhD scientist, often the first thing that you'll get is I may have a problem and I say, okay, here is something the vice president has been asking us to do in our group, and I haven't had time because we've got stuff we've got to get out the door. Can you please research this, literature, talk to the other people in the team, come back to me with what you think would be the best approach to get this started? That's very fuzzy, kind of undefined, but if I'm looking at a PhD, I'm thinking you probably have done this before, right? You did this for your PhD. Somebody gave you something that had never been done, and you had to figure out how to do it. No right answer, but you'd have the confidence and the independent learning skills. That's kind of squishy. Sure, I'd like to, it would be awesome if you'd come in and you'd know everything that we do here, but that's kind of unlikely. I may list that, hoping that I find that, but if in an interview you impress me with the right kind of mindset, kind of working, the work ethic, and you just seem like a good person to work with, I'm willing to give up on some of those things because I also figure you probably learn quickly, right? I'll bet 3 years ago you didn't know half of what you know now. In fact, one of the interviews in this book, Shaping the World, is a woman named Yasmin Saudagar. She founded a company called Neuressence in Toronto, and we were talking about hiring. And she said very directly, she said, a lot of job seekers imagine that I can always find a perfect fit for what, and that never happens. I can never find a perfect fit. She said, there's skills and knowledge. It'd be great if they knew all the science we use and the techniques we use. But it's really important to have a culture fit. Are they motivated by the things we do? Do they think in the way we need them to? Do they get along with the other team members? I can never find all of that. And I said, well, so Yasmin, what do you do then if you can never find everything? How do you make the decision? She says, I always go for the culture fit first. Because if I find somebody I think will be a good fit for the team, and these are totally non-technical strengths, right? That's what's most important. And if I have to spend a few months getting them up to speed, I'll have a far better team member. Whereas if I hire somebody because they have all the right skills and the right knowledge, but they don't fit, that's bad for all of us, right? Nobody wants that. So, yeah, I mean, there are many things we could talk about around this, but you don't have to have a perfect fit. It's rarely the case. This is another reason why just applying online is really hard because you have no idea what they're going to use to select, right? This is why talking to people, whether it's informational interviews, conferences, when there's a human being and we have a conversation, all of a sudden I start to imagine you being on a person on our team and what I want to work with you every day. And that is so powerful. And I might even decide, you know what, this guy looks great. I think he can learn some of these things. I'm going to go with it because there's a real risk mitigation in there that I can never know for sure. It is not a formula. It is absolutely a game. I have to take a chance, bring this human being in, and there's a lot of things I'm relying on, many of which are not technical. So,
Thank you.
insightful question. I hope that helps.
Yeah,
Thank
a
you so
lot of
much.
insightful advices. Yeah, sure. So, yeah, a lot of tips like be open-minded,
Yeah,
work ethics and your mindset. It's not just our technical things that works.
that's
So,
right. Yeah.
so thank you so much for taking the time to speak with us today.
You're
And
welcome.
we have learned a lot. I think each of those topics has a big session, and that's what you do in your business. Definitely. So thank you so much. And I would thank everyone who has attended the session today. We have more coming up in next month. So stay tuned. Follow our LinkedIn page for our next webinar session in November. Thank you, everyone. Have a good night.
Thank you. Take care.
Thank you.